Good morning. So in this unit of Algebra 2, we've been talking about systems of equations, and we've looked at linear systems. So I have a linear example here that we're going to talk about, but we'll be extending our study today into linear quadratic systems. That means instead of just seeing lines, you'll see lines with a parabola. So I want to remind you of the different ways that lines can interact. So I have an example of a linear system up here on Desmos, and if you notice, those lines don't look parallel, so they are going to cross somewhere. If I look, okay, I see them crossing, so this system of equations has a single solution. It's this point right here is where the two lines are crossing, -6, -11, so that has just one solution. An XY pair together make one solution, one point where those lines are crossing. Now, is that the only way that lines can interact? No, we had some other cases, right? The other weird cases that can show up. So we might have a system that looks like this. And these two lines, no matter where I scroll, these two lines are staying parallel to each other. So if I'm looking for where these two lines cross, or a point that would be on the red line and the green line simultaneously, can I find a point like that? No. So it ain't going to happen. So we would say that this system has no solution. And then the third possibility is that I could have, okay, so now look, purple line, red line, purple line, red line. What do you notice about the purple line and the red line? They overlap, they're the same line. So how many points would be solutions, would be satisfying the red equation and also the purple equation? Infinitely many, because those two are touching everywhere. So those are the three cases we can have. We can have one solution, we can have no solutions, or we can have infinitely many solutions. So I want to play with now how that can look if you have a line paired with a parabola. So I have a linear quadratic system graphed here. And so we're looking where these two functions intersect, the points that would be on the red parabola and also simultaneously on the blue line. And so I can see that that's happening twice actually. We have a point here and then we have another one down here. So this system has two solutions. There are two ordered pairs that satisfy both of those requirements. So what I want you to do is log on to Desmos and see if you can play with moving around either the parabola or the line and see if there are any other ways that this parabola and line can interact. Do they have to have two solutions? Do they have any other possibilities, kind of like the linear one? So go ahead and pause me and see what you can figure out. Okay, so hopefully you paused me there. So if I take my line and move it around a little bit, if I move it way down here, okay, so I have my line, I have my curve. Even if I zoom out, are these two things going to intersect ever? Do you think I'm ever going to get? I don't think so, because the closest they ever get is down here kind of close to the origin, and they are not going to cross. So this would be an example of no solution. So we can have two solutions. We can have no solution. Did you find anything else? Is there anything else that could happen here? Well, if I play with my y-intercept a little bit in my line, if I make it, let's see, maybe -1, maybe, oh, hey, look at that. Not quite. Let's see if I can move that line up just a little bit. Let's see, what if I try a +1? Okay, I think we're gonna see, yes, what I want to see here. If you look, I'm trying to zoom in so you can get a good view on it. Do you see how we just have a single, oops, that moved, sorry. We just have a single point where these are overlapping. I know you might be thinking, I see them overlapping for a bit here. There's actually only one point where they are overlapping. If I keep zooming in, they're very, very close at the other points, but there's just one point. We say that they are tangent to that point. This will come up in calculus a lot, so know that this will be a big idea as you progress in math. But it's possible to have just one solution if the parabola just sits perfectly on the line at a single point. So your possibilities possibilities in a linear quadratic system are you can have two solutions, one solution, or no solutions. In linear ones, we could have infinitely many. Are you ever going to get this parabola and line to hit at infinitely many points? Well, no, because a line has to stay straight and a parabola curves, and so those aren't going to hit at infinitely many points. So those are your possibilities there. Now, I know you know how to graph on Desmos. This was just so you could play with the equations easily. I think you probably could use extra practice with graphing parabolas by hand. So that's what you're going to do in your assignment. If you would like a refresher on how you do that, if you go to the September 14th module, that's when we went over how to graph parabolas by hand. So I would suggest you might want to look back there and refresh yourself there. So on your homework, I want to see an XY table. I want to see what x equals negative b over 2a gives you, if you need to find the vertex that way. If it's already in vertex form, you can identify the vertex easy enough. Make your little XY table so I can see you getting a couple of points, and then I want to see your picture. Okay, so you're going to be solving linear quadratic systems by graphing today. So I think that's everything. So remember that Jesus loves you, and so do I, so do your math.